There are multiple discontinuities here, for sure. In fact, let's give extra credit. Raise your hand if you can identify, actually just vote with your hand. So there's more than one, so is there 2 discontinuities? Are there 3? Is there 4? Is there 5? Show me with your hand. How many discontinuities are displayed on this function? Show me with your hand. Okay, if you're doing this, give yourself a 3 point. Okay, you need to memorize. Okay, look at my hand. I use this to help me remember 3 different things. Here are the 3 different things that helps me remember. One, there are 3 kinds of discontinuities I have to recognize. Vertical asymptote here at x equal -1. Removable here at x equal 0. Jump at x equal 2. So that's 3 different types. Go ahead. Oh, I'll talk about that in a second. Good there? Okay, so I'm using this to remember 3 things. That's one of the 3. The second thing it reminds me of is when dealing, if you're trying to find the, if a function is continuous at a point, the limit on the left must match the limit on the right, and it must equal the value of the function in the middle. That's this statement here. That will be tested on Wednesday. So, let's see. F is continuous at x equal a with the limit as x approaches a from the left of f is equal to the value of f at a, which is equal to the limit on the right. Question. So I've used this to remember one thing, the 3 types of discontinuities. Second thing I remember is the definition of continuity at a point. Third thing I remember is discontinuities. No, sorry, differentiable. A function is differentiable if 1, the function is first continuous, 2, there is no corner, and 3, there's no vertical tangent. So the corner is not an issue on this problem because it's not talking about differentiability. It's only talking about continuity. But you need me to do this again to help you remember. Okay, so just going through the whole sequence, I've got 3 things to remember. First thing, what are the 3 types of discontinuities? So I've got that. Second thing, what's the definition of continuity at a point? Third thing, differentiable. To be differentiable, a function first must be continuous. Second, the function cannot have a corner. And third, the function cannot have a vertical tangent. You would need me to do any of that again. I'm glad to do whatever helps. Good? So 3 things I'm remembering. First thing, what are the 3 types of discontinuity? Vertical asymptote, removable, jump. Second thing, definition of continuity at a point. Third thing, what causes a function to be not differentiable? So to be differentiable, must be continuous. Second thing I check for is it can't have a corner. Third thing I'm looking for is no vertical tangent. Not vertical asymptote, vertical tangent. So second thing you need to do on this problem is you must read really slowly. Graph of f is shown. Fine. The limit as x approaches b exists. And the function is not continuous at b. So that part we already identified. I could be looking at x equal -1. I could be looking at x equals 0. Or I could be looking at x equal 2. The function is supposed to be not continuous. That happens at those three. But the limit also must exist. For the limit to exist, the limit from the left and the right must be the same. As I get close to a vertical asymptote, the limit is unbounded. On the homework we did, one of the packets, the pink ones, there were several questions where there was a vertical asymptote, and the limit at that asymptote is infinite. So that's not going to be a limit that exists. That's a limit that doesn't exist because it's some number it's not a number. You need me to explain that again. At the removable discontinuity, let's go to the jump. At the jump, the left limit and the right limit will be different. The limit from the left will be 2. The limit from the right will be 1. So that limit doesn't exist because the left and right limits are different. The limit only exists here at the removable because from both the left and the right, the value of the limit is 2. Follow-up question. Do you need me to say anything again? You have a different question by raise of hand. Do you want us to go over? Is that
6?